Okay, so here's a heads up as to what I did with the meeting minutes. So if you log on to Blackboard, what I did is this, is I created, and I'm curious from your input, because I've never done groups on Blackboard before, so this is a first for me. What I did is I created 2 groups, okay, and the groups have each team in this class. Now I've also created a group assignment on Blackboard that has a group submission. So essentially the only 2 people that should be submitting are you and you, okay? Once you get your meeting minutes ready, we're going to use this as sort of a test run, submit them through there. Now if this doesn't work, like I'm not going to hold you all liable, just email them to me, okay? But if this works, then we can just set up a system to where you all can just deposit them on your own, and then it sort of takes the human element out of it. With as hectic a semester as I have, I don't want to hold you all at fault for like losing your minutes. So this would make it easier for me to keep track of them, and it makes it easier for all of you to know that everything's being submitted on time. So that's sort of why I want to go this route. Like I said, today this week they'll be due Friday, but usually they'll be due the following Wednesday. So next week's will be due on the 13th, and then they'll be due on the 20th. So we're going to typically have them due the following Wednesday, yes.
What all gets included with the minutes?
All right. What I want to see with the meeting minutes is as follows. I want to see, when you met, did you...
Well, I meant like you want some correspondence.
Yes.
And then do timesheets get turned in? Or is that something that we just file?
I'm gonna say let's just put those in the alternatives report. Just put the timesheets in the alternatives report. What I'm really interested in seeing with your meeting minutes is I want to see that you all have clearly defined tasks for yourselves. Like this person researches the cost estimate. This person develops CAD templates. This person starts looking at scheduling options. This person starts looking at girder options and da-da-da-da-da. So I want to see that. I want to see if there's any previous tasks that you listed from the previous weeks. This probably isn't going to make sense with this set of notes, but like week 3's notes, week 3's meeting minutes, you're going to have tasks that you talked about in week 2. Are they done? Are they still under, completion? Are they still being worked on? Where is the status? It's more for your sake than it is for mine. If you've ever seen, these types of meeting minutes, you'll see like action items. So, you'll bring up a topic. Let's say the topic is girder selection. So you'll have some discussion on that. And then you'll develop action items. Like Jason will do this. Joey will do that. Stuart will do this. And then on the next week's meeting minutes, the first thing you do is you go back to those action items. And you go, Jason, you were supposed to do this. Where are you at? Are you done? Are you not done because it wasn't supposed to take a week anyways. Like we gave that task to Jason. We knew it was going to take 3 weeks. So this is just the first week checking in on it. So you'll go back to those action items, see what needs to be done, and you sort of keep that forward progress. Keep the snowball rolling down the hill until next thing you know the project is completed. Does that make sense? Let's see. What causes you to get a bad grade on meeting minutes are meeting minutes that are vague and confusing and unclear. Again, not for my sake, for yours, okay? Does that make sense? All right. Like I said, we'll give this MU Online submission thing a shot. If it doesn't work, we'll just do it by email. We'll definitely submit, we'll definitely probably submit, if this works, we're definitely going to submit all the reports via Blackboard. And yeah, let me say one thing about Blackboard, and it's just something that I've sort of adopted teaching this class a number of times. I'm going to report just about every grade on Blackboard except for one. And the one grade I'm not going to report via Blackboard is your team evaluation grades, okay? And the reason why is that's kind of got to be confidential. There's something to be said about that grade needs to be confidential for your sake and for your team members' sake. You know, you're going to submit a team evaluation that ranks yourself and your other team members. I, I, I want to keep that close to the chest throughout the semester. Now, let me say this. If I get team evaluations and I've got 4 people on a team and everybody's getting a 90 or 100, I'll never bring it up. But if I notice that like lower team evaluations, I'll try and handle that respectfully. I'll probably pull them off the side and say, hey, you know, you kind of need to pitch in and whatnot. It's one of my ways to ensure that you all are staying on task. In fact, we're probably going to have, there's supposed to be 3 team evaluations this semester, and our first one is probably going to be very soon. Like I said, there'll be an Excel sheet that I give you. You fill it out and send it back to me. Again, rating yourself and others, and be as honest and open as you want. The only person that sees your team evaluations are you and me, so that's between us. Any questions on that? Yes?
So what you're submitting is like that spreadsheet that you had shared just earlier, like all the examples of what people have submitted. Is it just not like?
You're talking that little example. Yeah, essentially that. I'm not worried about the timesheets now. The timesheets, though, you all do need to keep track of your time, and I do want to see that for the alternatives report and the final report. Let me also say this about timesheets. It's not a competition. Okay, I'm not going to give you a higher grade than you because he has more time than you do. That's not what it is. I'm not really interested in who spent the most time on the project. What I am most interested in is that you are accurately documenting what time you have spent on the project. Okay? You need to get into that habit, not for my sake, but as we were talking before class started, we were talking about the consulting world. I mean, let me explain how this works. When you get a job in the consulting world, you know, you're going to get a job at, you know, some firm, and they're going to give you, you know, some projects. Well, those projects are going to have, you know, billable line items on it. If you spend 2 hours working on that project, that firm is going to take that 2 hours and they're going to bill it to that project. So you need to be able to track when you're working on a given project from start to finish. I mean, the golden rule you'll hear in consulting world is 15-minute increments. You know, if you spend an hour and 15 minutes working on a given job, that's going to get billed to that client. Okay, so you have to be able to do that. When I worked at an engineering firm back home, I mean, we would start at 8 o'clock in the morning and we'd end at 4:35 whenever we got back. But you know, at the end of the day, we would look and we'd say, you know, because we would do we'd go out in the field to be a lot of land surveying and site planning and things like that. We'd go out and we'd say, okay, we started at 8. We had from 8 o'clock to about 10:30 was going to the site or going to this house doing a land survey, and then we left at 10:30. So that was 2.5 hours billed to this job number. So that when, you know, the person who owned that house or the person who was buying that house or the client who was requesting that site plan or what have you, when they got the bill at the end of the day and they goes, well, why am I paying this amount? Well, here's why. You know, this is how many hours were spent on this and da-da-da-da-da. So, again, for your sake, not mine. Okay. Any questions on that, though? Yeah, I don't need that for the meeting minutes. I want that for the alternatives report. 5 p.m. 5 p.m. But let me say this. I'm being pretty loose this time. Like, Blackboard gives you crap and you email it to me Friday or Saturday, I'm worried about this time. But this will be the test run. Like, from here on out, I'll be a little more strict with it. Like, it'll be, you know, 5 p.m. And that's what I'm going to do. I'm going to make all the submissions in this course due at 5 p.m. into business. Like your reports, whatever day they're due, they'll be due at 5 p.m. and so on and so forth. Maybe not. It really depends on what you're doing. I understand it's early, so I understand that, you know, you're not going to have 7 tasks done right now. I mean, by the time we get to week 6, week 7, that'll be a non-issue. I just want to see whatever you are working on. I just want to see that you've clearly delineated it. If all it is just getting Google Drives and templates and stuff like that set up, then fine. Then just say that. One thing I think I'm going to do next week is I want to talk about the alternatives report. Because I think you all need, and we might even start doing that on Friday. I think we need a clear path at the end of the day. So I might present to you all the outline, like what the report's supposed to look like. You know, there'll be, I think for your alternatives report, there's going to be 4 chapters. There's going to be sort of an introduction chapter where you spell out the scope of the project, the generalities of it. It might be 4, might be 5 chapters, I'm not sure. But there's essentially going to be a first chunk of the report that's just generally about the project. You'll have 1 chapter on at least alternative 1, 1 chapter on alternative 2, and then your last chapter will be your selection methodology, why you picked what alternative you picked. And that'll be your alternatives report. Your final report will just tack on to that, where you take that final selection and refine it and do, you know, refine calcs and tweak your design to get to a final answer. But I have a pretty detailed outline that I've put together that, I mean, literally like section 2, 2.1, 2.2, exactly what you need to complete the report. And why don't we talk about that on Friday? How about that? Does that sound good? I want to really quickly get through the section properties calc because I think this is going to be fundamental to whatever bridge that you do. And then after we do that, I want to take some time and discuss loads on bridges, because bridge loading is going to be different than what you've done in structural analysis in steel and concrete, but it's not going to be difficult. Okay, so with that, let me just sort of jump right back into this. Oh, I opened the PDF. That's no big deal. So if you recall, we were looking at this, and we were looking at computing section properties of this particular element. We hadn't quite finished it, but I want to take some time and, oh my goodness. I want to take some time and finish out the composite section properties portion. So let me open this. So this is where we left off last time. So we had done non-composite properties here, and we were getting ready to do composite properties. So was everybody clear with everything that we did up here? Did that all make sense? Okay, well, let's take a look at the short-term composite section. Now, there's only 2 elements that you have to consider in the composite section, the girder and the slab. And the girder, we already have the AY and the AY and all this stuff computed because, well, we just did it. We just did that up here. So there's no need to recalculate the top flange web and the bottom flange and all that stuff because it's already there. So the only thing we really need to figure out is the slab. And it's actually pretty basic when you think about it. Let me go back to this. I want to look at this. All right. So one thing that's really important is this. Okay. Let's look at the centroidal distance. Okay. Now, how do we calculate that centroidal distance for a short-term composite section? Let me draw this a little more accurately over here because I don't really like the way that drawing is spelled out. Because what we've got, you know, a girder, we've got that. And then our slab is somewhere elevated, right? Make sense? And this dimension here is the haunch. Okay? So the first thing I want to do is I want to look at this y dimension. I propose that, remember, we're measuring this, oh my goodness, we're measuring this from the datum down here, right? But we need to go from the datum to that centroid on the concrete deck. So watch this. Tell me what's wrong with this. Do I go, okay, thickness, the depth, the thickness, the haunch, and then the slab? Do I do that? No, because I've counted for that twice, right? So I propose that to go from the datum to here, I go the thickness of the bottom flange, the web depth, the haunch, and then half the slab thickness. Ignore the top flange altogether because the haunch includes that. Does that make sense? Now, so let's do this. So equals that plus that plus that plus that divided by 2. Make sense? Now here's the nice thing about this, this calculation. This is the short-term composite section, okay? Now here's the difference between the short-term composite section and the long-term composite section. It's just a different size deck. But does that centroidal distance change from here to here and from here to here? That's the same, okay? So what I'm going to do is this. I'm actually going to actually copy this table. And we'll put this maybe like down here. We'll call this long-term composite section. Maybe give it a, I don't know, a different color, something like that. And then this distance right here, I'm just going to set it equal to that. All right? And notice how these are already referencing that. That's referencing that. That's referencing that. Whoop. And that. Actually, these were already correct, but I'm just going to go ahead and replace them anyways. That. And then that. Everything that you see here in this table is actually going to be the same for the short term and the long term. Does that make sense? Because the distance, that's the same. Okay? Now, the only thing that's going to change is this value and this value. The area and the moment of inertia. Let's talk about the areas. Okay? Now, the area of this slab is the width times the thickness. Now, I propose the thickness is the same for both. It's 8 inches, right? The thing that changes is the width. In this case, it's B effective divided by N. In this case, it's B effective divided by 3N. So, for the areas, all I have to do is take the thickness times the effective flange width divided by N, and in this case, take the thickness times the effective flange width divided by 3N. Oh, whoop. Yeah, no, that's right. I thought I had that in the wrong section. Does that make sense? So here the area is like 102 square inches. Here it's 34. Now remember, what we're saying is the concrete deck's area is much larger than that. But if we take the concrete deck and convert it into an effective lump of steel, it's an effective lump of steel with an area of 102 square inches. That's what we do when we divide by N. The reason why we're dividing by 3N down here is because we use the long-term section for those permanent loads that are on there always. And over time, concrete tends to lose some of its stiffness, things like that. So over time, that long-term composite section is going to lose a little bit of stiffness. So that's why we do that. Does that make sense? For moments of inertia, it is simply just, let me go back here. So moments of inertia, it's the width times the thickness cubed over 12. The only difference is the width changes. So here, go here, so we have the width. So the width is that divided by the modular ratio times the thickness cubed divided by 12. Bam. And then everything else is filled out. Okay? For this one equals the width divided by 3N. Wait. Oh, okay. Times thickness cubed divided by 12. Does that make sense? Here's the best part. Let me erase this little diagram right here. Here's the best part. What's the difference between the exterior girder and the interior girder? It's the effective flange width, right? What did it go from, 102 to 120? Or something like that. It was a wider effective flange width. Watch this. Change that to 120. Bam. Your properties are computed. That's the beauty of Excel. This is actually a lot to do by hand. You know what I mean? But with a little bit of clever Excel, copy, paste, bam, it's done. Again, let me pull up my little template that I prepared, like when I taught bridge engineering and whatnot. I have one single sheet. Now, you do this however you want. I have this set up to where if I print it, it all sort of prints out on one sheet. But if you'll notice, it does non-composite, short-term and long-term, interior, short-term, or short-term and long-term exterior. And it computes all the properties in a very clear, simple, professional manner, and it all comes out on one sheet. And it looks pretty well when you print it out. You all can format this however you would like. But if you notice, it's set up a lot like engineering calcs, you know, written by, checked by, da-da-da-da-da. I also made it a point when I developed my spreadsheet, anything that was an input, I sort of highlighted that as an input. So if you'll notice, that's why all these colored cells are colored. You know, they are inputs. Everything that has sort of a white background, that is a compute value. Notice I'm not even putting in the modular ratio. Like if I highlight over the cell, like let me do this. Like look at the formula. I'm basically rounding 29,000 divided by 33,000 times the square root of FC prime, 1.5 times square root of FC prime. I'm rounding that to the nearest whole number. So I'm computing E for the concrete and taking ES divided by EC and rounding it to the nearest whole number. See, we've been using a modular ratio of 8 because we're assuming we're using 4 KSI concrete. What if we're using 6 KSI concrete? You see what I mean? I wanted the spreadsheet to be as robust as humanly possible. Okay, so if it's not a desperately needed input, I have the spreadsheet compute it for me. It takes a little bit of work, but the more work you put in on the back end, the easier the spreadsheet's going to be in the long run. I've done senior design projects of this nature before, and it's a really cool moment when each of the students in the group come together with a different component of the design. Like you do the service limit state, you do the strength limit state, you do the cross-section proportion limits, you do the dead and live loads, and then everybody's tweaking the dimensions, and everybody says a dimension. Okay, does this work? No, it doesn't work for service limit state. Okay, let's all bump up the flanges, and then together they're able to actually tweak the girder. It's actually a pretty cool moment, but it only works if you've got robust enough spreadsheets. If you're having to hard code everything, it will take forever. So a little bit of work in the back end will make your lives a little easier. Cool moment, I did. Yeah. Those jokes are just sheer gold, I'm telling you. I was looking for a reaction out of you all with that one.
Here we go.
See, I could even start throwing in some jokes, like some really good ones. Like these jokes are just virtually awesome. Yeah.
We should just
Virtually.
That's a stretch. We'll take these recordings and just literally cut out
The technical matter. And just
from every class and just make a mixtape.
Somebody said something like a couple, like I think it was a year or so ago, they were going to start a Dr. Michelson Twitter account and just start tweeting out these really horrendously bad jokes.
We can take the lecture videos and cut the technical material out and be like, there's a whole bunch of, it's like a new trend on YouTube. Have you seen like, it's the movie Cars, but without cars?
I know. I think I know what you're talking about.
They cut it up, so it's just like scenery, and it's 3 minutes long, the whole movie.
Let me stop this.